Hello everyone, welcome to my program club. Today we will be solving the problems of weekly contest 359 on Leetcode. Now let's move towards the first problem of the contest, and the name of the first problem is check if a string is an acronym of words. So given an array of string words and a string S, you have to determine whether S can be an acronym of words. What it means by this statement. For example, let's take this example. When we take the first letter of each word in this words array, and we concatenate them in this sequence, which is the sequence of the words in the array. So let's take the first letter of the first word, first letter of the second word, and first letter of the third word. It will be A, B, C. So this is indeed an acronym of the words array. So we will return true. Otherwise, we would have written false. So the string S is considered to be an acronym of words if it can be formed by concatenating the first character of each string in words in order. For example, AB can be formed from apple and banana by taking their first letters, but it cannot be formed from beer and the work. So I hope you understood the wrong statement. Now let's look at the constraints. So the constraints are pretty low. The length of the words is of order 10 raised to power 2, and each word is of length at max 10, and length of the string that will be given to you to check for acronym will be 10 raised to power 2, order of 10 raised to power 2. So it is given that each word is having only lowercase English letter. So what will be the approach to solve this problem? We will just iterate over the given words array once, and for each word in the words array, we will be taking its first letter. For each word in the words array, we will be taking its first letter and forming a acronym. At last, we will check our acronym matches with the given acronym. So accordingly, we will be returning true or false. So that's the first problem of the contest. Let's try to submit it. So the time complexity will be of n, and here is the length of the words array, and the space complexity, if you consider the space required to form this result string, it will also be of n, because we are taking first letter of each word. Now let's move to the second problem of the contest. So this is the second problem of the contest. Its name is determine the minimum sum of k avoiding array. So you are given two integers n and k, an array of distinct positive integers is called k avoiding if there does not exist any pair of distinct elements that sum to k. Return the minimum possible sum of the k avoiding array of length n. So it is understood that to get the minimum sum, you have to take the minimum of the numbers. And let's have a look at the constraints. So constraints here are also pretty low. N and k are both of order 50. So what we will do is uh, to minimize the sum, of the k avoiding array, we have to take minimum numbers minimum n numbers which will result in k avoiding array. So we will gradually pick those numbers which will result in k avoiding array. Basically what we have to check is for a number to be included in k avoiding array, it should not form a sum with any other number that is currently present in k avoiding array. While the array is being formed. What I mean by this is, for example, I will explain it in the coding part. Basically, what we are checking is we will keep forming the k avoiding array from numbers 1 to a sufficiently large range, so that whenever we include a particular number, we will be moving from 1 to, let's say, 1000 or 10,000. It will be sufficient range to include all the numbers that a k avoiding array would be having, because the k's value is of maximum 50. So we will first add a number if there is no other number present in the k avoiding array form till now that is having sum with the current number as k. So let's quickly move towards the coding part. Here you will be able to understand what we have done to solve this problem. So what we have done is we have taken a set to check for the elements present in k avoiding array till a particular point, or say number, in O one time. So This number would be sufficiently large. I have taken it 10,000 to form all the k wording arrays, because here you can see that k's value is at max 50. So this is sufficient. So we will add the current number num in the array if the number is not forming a pair with any other number present in the k avoiding array till now. Then we will add that number to the numbers that will be used to check the elements in the k avoiding array. And at last we will return the sum of the k avoiding array. At last we will return the sum of the k avoiding array. So let's quickly move to the third problem of the contest. And what will be the time complexity of this problem? Time complexity will be order of 10,000, which you can say as order of n also, if you may like. So it is a linear time complexity, and this, and we will break as soon as, yeah, it's order of n only. We will break as soon as the size of the array reaches the value n. So both time complexities and space complexities will be order of n at max. So let's move towards the third problem of the contest. The name of the problem is, the third problem of the contest, maximize the profit as a salesman. So you are given an integer representing the number of houses on a number line, and the houses will be numbered from 0 to n minus 1. Additionally, you are given 2D integer array offers. Each offer is the form start, end, and gold. So each client will be wanting to purchase the houses starting from the start index and ending at the end index, or say houses numbered from start to end, both included, and he will give you gold I amount of gold in exchange of those houses to you. So the problem statements also says that, indicating that the ith buyer wants to buy the houses from the range start to the end for gold I amount of gold. So as a salesman, your goal is to maximize the earnings by strategically selecting the houses in such a way that your earning is maximized. And then for those houses, you will selectively pick the buyers which will be giving you maximum returns on your selling of the houses. So you have to return the maximum amount of gold that you can make. So note that buyers can't buy the same house. For example, a single house can be bought by only a single buyer, not by multiple buyers, and some houses may remain unsold. It will not be possible that all the houses will be sold in some cases. So that's pretty much it for the problem statement. Now let's look at the constraints. So the number of houses are of order 10 raised to power 5, and the length of the offers array is also same, 10 raised to order of 10 raised to power 5, and each offer will be of length 3, and the start and end, the ranges of the houses will be indeed the between the house numbers which are 0, 2 and -1, and the gold will be from 1 to 10 raised to power 3. So first of all, you may think that you can greedily pick those ranges which are giving you maximum, uh, let's say maximum gold in total. But let's say I decide to pick this range. Then based upon if I pick this range, I have to know which previous ranges I have picked. So this range amount of gold will depend upon which previous ranges you have picked. If let's say you have picked a range which is coinciding with this range, for example, this, let me take this example to the board. Let's mark the ranges. These are the houses on the number line: 0, 1, 2, 3, and 4. So the ranges are like this. Red is denoting this range. It will be 0, 0. So this is the range, and it is providing you 1 gold. Now this range is denoted by blue. So it will be 0 to 2. And this is providing you 2 amount of gold. Next range is from 1 to 3. Let's denote it by this white color. 1 to 3. It is giving you gold 2. So these are the ranges. Now if let's say you decide to pick this range, particular range, let me change the color quickly. It is fine, I think. Let's say you decide to take this range, or say take this buyer. So you have to know which previous ranges you have selected. If you have selected a previous range which is coinciding with this range, then you cannot select this range. For example, if you have also selected this range previously, then you cannot select the range from 1 to 3. So I hope you are able to understand. So we cannot apply a greedy solution. Greedy solution won't work. You have to try out all the possible combinations of ranges. You have to try out all the possible combinations of ranges. Ranges are the ranges in which buyers are looking to buy. And such ranges which are not coinciding, which are not overlapping. Because it is mentioned that a single house can be bought by only one buyer. So you cannot have buyer uh, which are having overlapping ranges of their buying choice. So let's say these are two buyers. Let me quickly change the color. Let's say this is buyer number 1. This is buyer number 2. You cannot have these two buyers in a same combination because their houses of interest are coinciding. So same house cannot be bought by both of the buyers. So this is why we will have all the combination of ranges which are not overlapping. And greedy solution won't work. So we have to try out all the combinations. Now to try out all the combinations of brute force way will be, we have to decide for each buyer we have to decide either to include him in our buyers list, maximize profit, maximize amount of gold, or say profit, or to not include him, exclude him. So for each buyer, we will be having two options, and this will continue. And how many times this two will be multiplied? It is nothing but the length of the offers length, which is 10 raised to power 5. So 10 raised to power 5 offers will be made at max. So for each offer, you will be considering whether to include this offer or not. So it will be 2 into 10 raised to power 2 raised to power 10 raised to power 5. So I hope you are able to understand. So it will be very high. It will be greater than 10 raised to power 8 operations. Let me quickly change the color. Allowed in 1 second. Basically, if the number of operations of your program exceeds or become equal to 10 raised to power 8 operations, which are allowed in 1 second, then you may get a TLE, time limit exceeded, and your solution will not be accepted. So you have to optimize this brute force. Now let's have few observations how we will be making the optimization. Let's mark the offers of the buyers with indices. Zero, 1, 2, and let's take another one. 3. These are the offers. You have to select the offers basically. So let's say a combination of choices of offers, something like this. And there is another combination of, this is one combination of choices of offers. Now let's say we are considering another combination of offers, choices. It is also pointing to 3. Now you can see this is a combination. Let's call this combination 2. You can see 3 is being value for 3 will be calculated twice. Will be calculated more than once. This is one observation. Let's call this observation 1. Now let's quickly move to the another observation, and let me copy this dummy input. Yeah. And what was the choices that we were making? 0, 1, 3. Let's consider the choices 0, 1, and then 3. So the third choice, let's consider this choice. there will be two choices for this indexed offer. Either to include it in combination or exclude it. So it will depend upon the previous choices. The decision will depend upon the previous choices that you have made. The decision will be dependent on previous choices you have made, because we cannot have offers with overlapping ranges. So it can be observed that, let's call this a big problem. It is dependent on the solution of the subproblems. Let's call it subproblem 1, subproblem 2, subproblem 3. Solution for big problem. Let's call this solution B. And let's call this solution of subproblem solution sub 1, solution sub 2, solution sub 3. So these solutions can be combined to form the solution of the bigger problem. This is observation number 2. This property is called optimal substructure. Those of you who are new to this property, I will be providing a link for it. A link will be provided to you. And the previous observation, this observation 1, this is called overlapping subproblems. Since you will be doing extra work for this subproblem. And also, those of you who are new to this property also, I will be providing a link for it. Link of an article describing these two properties, and these two properties are necessary properties to have to apply dynamic programming on the brute force. So dynamic programming is nothing but storing the result for previous states in order to avoid extra work for calculating result of those previous states again if they are visited again. So it will be saving your extra work. Also, another thing that you will be doing is making solution of a larger problem based upon the solution of its subproblems. So these are two things that dynamic programming does in order to solve a particular problem. And those of you who are new to dynamic programming also, I will be providing a link to it also. Link of article describing dynamic programming. You can explore that link and then you will be able to understand it in a much clearer way. So let's say for this particular house index, for now let's consider these are the house indices. So let me quickly move to a new slide itself. Let's mark the house indices 0, 1, 2, 3, 4, and so on. Let's say till n houses. And these are house indices. Now, if we know the result, let's say we know the result of this, we know what will the maximum profit till this house index by considering deals ending at this house index or before it. So by considering all the deal with the ranges before this house index, all the set of deals, if we know what will be the maximum profit, profit is nothing but gold, maximum gold amount, maximum profit till this house index. Then we can accordingly form the result of the further house indices depending upon the deals closing there. So how we will be doing so? I will explain it in the coding part of the solution. Now let's quickly move towards the coding part. So profits will be considered. This is the profit according to the endpoints of the ranges of offers made by the buyers till a particular house index. So these are nothing but the house indices, profits till a particular house index, max profit. So these will be the deals offered by the clients. Deals or say offers made by the buyers ending at a particular house index. For the current deal ending at the house index O of 1, which is nothing but the endpoint of the range of number of houses of the current buyer's index, current buyer's interest. This will be the end of the house number, which is of the interest of the current buyer for the current offer. And we will be adding all such offers according to their offers and range. And we will be storing their start of the range of the offer, start of the range of offer, and other one will be the profit that offer is providing us. So what you will do is, for each deal, we will be traversing over the house indices as we have talked about in this approach. B, calculating the maximum profit that can be made by considering all the deals or offers whose endpoints lie on or before a particular house index or say house number. So for each deal with H index ending at house index, we will be checking for two conditions, which are either we will take that deal if we decide to take that deal, then we will consider only those deals which are not overlapping with the current deals start. So how you will be determining that two deals are overlapping? Let's say this is deal 1 and let's say this is deal 2, and it is ending at this house index, let's say H index. Now what will be the deal which you will be considering to include this with this particular deal. All the deals that are not overlapping with the current deal. So let's say left L1 is the left boundary of the current deal, R1 is its right boundary, and L L2 is the left boundary of the deal 2, and R2 is the right boundary of deal 2. This is deal 2, this is deal 1. So in order for them to not overlap, what will be the necessary condition? That R1 should be lesser than L2. So the end point of the previous range should be lesser than the start point of the current range. And if we are to avoid the extra work of calculating the results for previous deals, that would make a correct combination with this particular deal. What we will do is we will subtract house index we will just check for the result of, let me change the color. Check for the result of house index equal to L2 minus 1. Because this will be the end point of the deal that would have been closed at this particular index, and it will not overlap with our current deal, which is D2. And we will add the profit of current deal. This is if we decide to take the current deal. And if you decide to ignore the current deal, let me quickly change the board, the slide. If you decide to ignore current deal ending at H index, then you will simply continue with the profit at previous house index, which will be nothing but profit of current house index will be equal to profit of previous house index. So these two will be the choices according whether you have decided to take the deal or not. So for each deal ending at this particular house index, you will be making the choice and you will be picking maximum of it. This is you taking a deciding whether you will take the particular house index or not. This is if you decide not to take the current deal. current deals ending at H index. So according to your choices, you will be returning the final answer, which will be the profit at the n minus 1th house. Then you will return the profit at the n minus 1th. So this wraps up the third problem of the contest. Let's try to submit it. As you can see, it's getting accepted. So let's move towards the last and the final problem of the contest. So the problem's name is find the longest equal subarray. So let's read the problem statement. So you are given a zero indexed integer array nums and an integer k. A subarray is called equal if all of its elements are equal. Note that the empty subarray is also an equal subarray. Return the length of the largest possible equal subarray after deleting at most k elements from the nums. A subarray is a contiguous, possibly empty subsequence of elements with an array. So let's take an example. Let's take this example. Understand the problem statement in a better way. Now we can make at most k deletions. And find the subarray of largest length such that all the elements in subarray are equal. For example, let's take this subarray. 3, 2, 3, 1, 3. Now what is the maximum frequency of an element here? 3 is having maximum frequency. But since we have to consider a subarray of equal numbers only, we have to make deletions. We can delete these values, and the number of deletions were less than equal to k. So this will be a valid subarray. And after these deletions, all the elements will be same. And this will indeed be our answer also. So the maximum length of the subarray you can achieve is 3. So you will return 3. So this is what the problem statement is asking you to do. Now let's have a look at the constraints of the problem. Length of the array will be of order 10 raised to power 5, and length each value in the array will be of order of length, and k will be either equal to 0 or greater than it, or it will lie in this particular range between 0 to length of the array. So How you will be doing this problem? If we can apply a greedy approach on this problem, what we will do? For each element in the array, we will store the indices on which this particular element occurs in the given input array in ascending order. What I mean by this is, for example, let's take this example again. Let's mark the indices of the given array. Now let's consider the first element that we encountered, 1. What are the unique elements? 1, 3 and 2. What are the indices? These are the elements. And these will be the indices at which they are present. One is present at 0 and it's present at 4. So we have checked for 1. Now let's check for 3. 3 is present at 1, 3 and 5. Now 2 is present at only one index, which is 2. So let's look at the difference between these indices. Excluding these two indices, it will be 3. Between 0 to 4, there will be only 3 indices, 1, 2 and 3. This will be 0 and this will be 4. So I hope you are able to understand what we are doing. So these will be the number of deletions required if we decide to form a subarray with only ones. Number of deletions required if we decide to form a subarray with only ones. Similarly, we will, and accordingly, we will be checking what will be the maximum length we can achieve for each element. What we will check for each element while staying in the bounds of in limit of k deletions, what is max length subarray that can be formed. So number of deletions are 3. You have already done 3 deletions. You cannot have a length. You cannot have a length further than this. Then you have to start from this index if you want to check further. For example, this also only one deletion is required for this. Only one deletion is required. In total, 2 deletions are required. And it is in the boundaries of 3. And what is the length? 3. So 3 will be our answer. So this is how we will be forming the answer. So it will be more clear to you in the coding part. Now let's quickly move towards the coding part. First, what we will do is, this is to store the indices at which a particular element occurs in the given input array. Indices will be stored in ascending order as we traverse the input array. So this is we storing the indices for each element. At which each element occurs in the given input array. This will be the maximum length of max length subarray. This will be the length of max length subarray. Which will be found by making at most k deletions in a subarray of the input array. So for an element, this vector or say array will contain all the indices of its occurrence Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the solution of its occurrence in the input array. So what you will do is, this will not be used. Considering 2 pointers, we will make use of 2 pointer technique. which will form a sliding window. To calculate the max length of the subarray. Now consider is something like this. Uh, Let me take a new slide. Let's say there are two pointers. Let's say this is the array of the indices. Indices at which say X occurs in the input array. Let there be a pointer for left here, another pointer right. What is the number of indices between these two pointers? Number of indices or say occurrences of X between left and right. It will be nothing but right minus left plus 1. Okay. Now let's say this is, let's call this index left. Let's name this array as index. And its value of this index will be index right. How many indices will be between these two values? How many indices between index left and index right? It will be nothing but index left. So index right minus index left plus 1. For example, between let's say indices with value 2 and 5, how many indices will be there? 5 minus 2 plus 1, which will be 4. 2, 3, 4. As you can check, 4 indices are there. So what will be the deletions required to form this particular length subarray? What will be deletions required? Let's call this value as value 1, and let's call this value as bottom one as value 2. Deletions required to form a particular deletion required to form a subarray of axis of length right minus left plus 1. It will be value 2 minus value 1. I hope you are able to understand. So if the number of deletions, these will be the number of deletions. If the number of deletion is greater than k, then you will keep moving your left pointer towards right. And when it becomes equal to or less than k, then you will update your maximum length of the subarray possible. This is what we are doing here. This is a sliding window technique. Basically, the window is this window, the window between left and right. This is the window. And we will return the maximum length or max count. Let's try to submit it. As you can see, it's getting accepted. And that's wraps up the final problem of the contest. If you are having any doubts in the problems, please feel free to ask them in the comment section. I will be more than happy to answer them. So thank you for watching. Thanks.